Greetings, everyone. In this short video, I would like to discuss an unusual way of looking at the quadratic formula. I believe we all know from high school geometry and algebra that quadratic formula looks like this, and I'm going to just write it down here. If you have a general quadratic equation, ax squared plus bx plus c equal to 0. Quadratic formula basically is the solution in terms of a, b, and c that solve this quadratic. It's quite well known, but what I would like to do today is something different. Given any quadratic equation, you can always divide the quadratic equation by the leading coefficient a, so that in reality all quadratics look like x squared plus some coefficient b times x plus some constant c equal to 0. So what I'm trying to basically say is the coefficient a is really redundant. Now imagine that you have three axes, coordinate system here, and imagine normally it's the x, y, z coordinate system, but imagine that we had an x-axis which is pointing directly above here, and then imagine you had a b-axis and the c-axis such that for every b and c value you pick, you ended up with a particular x value that is the solution of this quadratic. It's a crazy idea, and I have to credit Judah Schwartz of retired Harvard Grad School of Education professor for this idea. Imagine you could do that, and I'm going to also share with you one of the sort of secrets of Macintosh computers. If you go to the search option here and type the word grapher, you're going to realize that deep in the bowels of the utilities is an unbelievably versatile software called Grapher, and it has all kinds of capabilities, including a three-dimensional graphing. Now, when I type this equation, as you notice, nothing happens because by default the coordinate system is not x, b, and c axes. It's the x, y, z axes. So what we're going to do is we're going to hack this. I'm going to call the good old x coordinate z. I can always do that. And then instead of a b and a c, which the computer doesn't recognize, I'm going to call the b axis the good old x-axis. I'm going to call the c value, the c-axis, the good old y-axis. And when I do that, observe, we get this fabulous surface, which, believe it or not, you're looking at the space of all possible solutions of the quadratic formula. I strongly recommend, if you especially are a Mac owner, you explore this on your own. And all I did was I typed z squared plus xz plus y equal to 0. So that means for all possible x and y values, I'm going to have a associated z value via the quadratic formula. And what you're looking at is all the imaginable solutions here for the quadratic formula. Observe that there is a region that is sort of forbidden, and this is the region where the discriminant is undefined because it becomes, the discriminant becomes negative, thus the square root under the square you have a negative number, so the quadratic formula basically tells you that there are no solutions. And I find it quite interesting that that boundary itself is parabolic in nature. You also notice that this is a surface that is folded over itself, which shouldn't be terribly surprising if you think about what quadratic formula looks like. There's always a plus and a minus version of the solution. And right at the boundary here, you notice that this is where you have your double roots. But it's quite a fascinating take on the notion of quadratic formula being explored in 3 dimensions as a surface. And this was just a simple idea once you had the insight that you could make the parameters, the coefficients b and c, independent variables, and then plot the associated x value, or z in this case, so you can see. I hope this was not too confusing, but it just gives you a sense of what technology would allow us to do. Alrighty, I hope you had a good time. Take care.